Hi everyone. In the given problem statement, we are going to count the number of complete tree nodes. Basically, how many nodes are there. So it's pretty straightforward and simple solution to be done. So let us take this example. So 3, 4, 5, and 6. So here, right, according to Wikipedia, what is a complete tree node? So any tree node that is completely filled binary tree and all the nodes in the last label are far left as possible. It can be between 1 and 2th node inclusive of the last level h. Design an algorithm that runs in less than big O of n time complexity. So it's a very straightforward problem. There is not much to be done. So one you can do through DFS or recursively. So let me, if I have to do it right, let's say if I have to solve this problem recursively. So DFS, or I can just totally count the number of nodes. So here, right, I can type in root. So if not root, then just return the value. Else we are just going to say return 1 plus DFS root dot left plus DFS root dot right. So that's pretty straightforward. So here, right, the first value is going to get counted as 1, then 2, 3, 4, 5, and 6. So all the values, right, is going to be come in this node. Then it is going to be coming it out here. Let's see if I have to count it out, right? So here would be 1, 1, 1. So all of them, right? So 1 plus 1 plus 1. So this value is going to be 3 and it's going to be 2. So 3 plus 2 plus 1 is going to be 6. So that's the idea, and 6 is going to get returned. So that's the entire idea of this algorithm. Just doing it recursively, or you can run, or you can take a stack, do a in order, pre-order, or post-order traversal and keep the elements. Just you have to check that you have to ensure that the last is completely filled in a binary tree. So you have to check the condition of the complete tree nodes, and once that is done, we are good to go. So that's all out here for the explanation. Let us jump to the Python solution. So here, right, if I have to do or solve the solution recursively, so we are going to check if not root, then we are going to return 0. In all the other cases, we are going to return 1 plus self dot count nodes root dot left, and also have to do and check the right subtree also. So self dot count nodes root dot right. That's all. I hope it runs properly. So the public test cases got passed, and here, right, it is a big O of n solution, so which is pretty efficient. So let me check for the one. So yeah, it ran successfully. So that's all for this video. See you in the next one.